Welcome to The Explainer. Today, we're tackling a name in data science that, let's be honest, trips almost everyone up: logistic regression. It's a super powerful tool, but that name, it's just confusing, right? Well, by the end of this, you're gonna get it. You'll know exactly why it's called that and, more importantly, how it actually works. All right, let's start with something super simple. A question you might have even asked this morning. Will it rain tomorrow? Now, think about the answer you're looking for. It's not a number, is it? It's a simple yes or no. Or how about this one? A classic classroom worry. Will a student pass or fail? Again, we're just looking for one of two outcomes. We don't really care about the exact score, just which box they land in, pass or fail. And then there's this one, a battle our inboxes fight for us hundreds of times a day. Is this email spam or not? It's a simple sorting job, right? But it's so important, and it all happens behind the scenes. Okay, so you see the pattern here, right? The big thing connecting all of these questions is that they're not asking how much or how many. They're all asking for a choice between just two things: a simple, straightforward yes or no. So in this yes-no world we're talking about, it turns out machine learning has a tool that is tailor-made for these kinds of two-choice questions. And that tool is called, you guessed it, logistic regression. Now, the key thing to get here is that its main job isn't to spit out a number. Nope. Its job is to calculate the probability of something happening. How likely is it to rain? What's the chance this email is spam? And that brings us right to the heart of the puzzle, the thing that makes this name so darn confusing for so many people. Okay, so here's the big question. If this thing is all about classifying, sorting things into boxes like pass or fail, spam or not spam, then why in the world does it have the word regression in its name? I mean, regression is for predicting numbers, right? Like predicting the price of a house. What's going on here? Well, the answer is actually pretty simple, and this is the key. Under the hood, it is using a regression-like formula. But, and this is the magic part, it adds a clever little twist right at the end. It takes that raw number and transforms it into something completely different, a probability. So what is the secret twist? What's this S-shaped secret? Let's take a look at the special ingredient that makes it all work. The secret is this really cool-looking S-shaped curve. It's called the sigmoid function, and its job is super specific. It takes any number you give it, any number, positive, negative, huge, tiny, and it just squishes it so it fits neatly between 0 and 1. Seriously, you don't need to worry about the math formula behind it. Just think of it as a probability converter. It's like a machine that takes in a random number and spits out a perfect probability on the other side. Simple as that. And once you have that probability, the decision part is actually a piece of cake. Look, it's basically a three-step process. First, the model calculates the probability, say a 0.75 chance of passing. Then, it just compares that to a simple cutoff point, usually 0.5. Since 0.75 is bigger than 0.5, boom, the prediction is pass. It really is that straightforward. All right, this brings us to the big reveal, this side-by-side comparison, where that confusing name, logistic regression, is finally going to make perfect sense. And here it is. This slide just lays it all out perfectly. On the left, you've got your standard linear regression. See that straight line? It's predicting numbers that can go on forever. But on the right, that's our guy, logistic regression. It uses that awesome S-shaped curve to predict a probability, which is always stuck between 0 and 1. And that's what makes it perfect for classification. So there's the secret. It's got the engine of a regression model on the inside, but the output of a classifier on the outside. Okay, so you might be thinking, that's cool, but in a world with all this super complex AI, neural networks and all that jazz, does this simple little model still even matter? Oh, it absolutely matters. You might not see it, but it's like this invisible engine humming along in the background of your daily life. It's in your email fighting spam, it's at your bank checking for fraud, it's even helping doctors and businesses make better predictions every single day. Its fingerprints are literally everywhere. And you know what? It's not going away anytime soon. Even as we look ahead, logistic regression is still a powerhouse. Why? Because it's fast, it's efficient, and maybe most importantly, it's interpretable. That's a huge deal. It means we can actually understand why it made a certain decision. In fields like finance or medicine, that's not just nice to have, it's absolutely essential. It really all boils down to this powerful idea, one that's easy to forget in tech sometimes. Better doesn't always mean more complicated. And that's really the big takeaway here. The reason logistic regression has stood the test of time is because it hits that sweet spot between performance and practicality. It's a tool that not only works really, really well, but it's also something you can actually explain to other people. And trust me, that's often just as important.
So that leaves us with one final thought to chew on. In a world where AI is getting more and more complex, almost like a black box, it's worth asking, when is the simplest answer also the smartest one? Thanks for joining us for this explainer.